this loop, then we will get the voltage across the VAB, nothing but this. Suppose VAB of t equals to IR plus V1 of t. So here I we can write as C dV1 of t by dt. Hence VAB of t is nothing but RC dV1 by dt, because V1 is a function of t, there is no need to indicate separately. So V1. Hence option D is correct. Question is, consider the following circuits. Which of the following statements is correct? Figure A and figure B. Okay. Suppose if we look into the figure A, what is happening here is, here the output of the first transistor is feeding into the second transistor input. Means it is kind of like cascade connection. Whereas comes to figure B, here this is IB, here this is 1 plus HFE IB, here is 1 plus HFE square IB. Means what? Here we are getting the multiplication of the current. This is kind of near Darlington connection. Hence figure A is a cascade connection, figure B is a Darling connection, hence option B is correct.
They have given three equations: 4x plus z is equal to 5, x plus 2y plus 3z is equals to 1, and minus 3z minus y is equals to 3. We have to find the values of u23 and L33 by using LU decomposition method. Now, the given equations can be written as Ax is equals to B, that is nothing but converting the linear equations into matrix form, and this matrix A can be written in LU decomposition form. So L into U, L is nothing but the lower triangle matrix, whereas U is nothing but the upper triangular matrix. Now, if I substitute the value of L, which is L1100, then L21, L220, L31, L32, and L33. Similarly, the next one will be 1, mu12, or it is nothing but U12, U13, then 01, U23, 001. Now, this matrix, these two, product of these two matrices is nothing but A, which is 4, 0, 1, 1, 2, 3, 0, minus 1, and minus 4. Now, let us multiply the LHS and equate the values to RHS. So, if I consider the first row and first column, the values of L11 will be 1. Then the value of L21 will be 1. Similarly, L31 will be 0. And also L11 U12 equals to 0. And L21 U12 plus L22 will be equals to 2. L22 is equals to 2, since the value of U12 is nothing but 0. Now, this is nothing but just multiplying and simplification. Next, if you go for the second, then L11 U13 will be 1. So U13 is nothing but 1 by 4, since the value of L11 is 4. Now, L21 U13 plus L22 U23 is nothing but 3, whereas U23 is nothing but 11 by 8, because L21 is 0, L21 is 1, and substitute the value of L31, which is 0. And if you simplify, it is U23 equal to 1 by 8, 11 by 8, which is 1.375. Similarly, if you simplify, you will get the value of L33 as minus 2.625. Then option C is correct. Is f of x, which is e power cos x into sin x if x lies between minus 2 and plus 2, including minus 2 and plus 2. And for any other value of x, it is 2, that is, the function is 2. Now, you have to find the value of minus 2 to integral minus 2 to 3 f of x dx. Now, clearly we have interval minus 2 to 2. And then for any other value, it is 2. So, we will split this integral into minus 2 to 2 f of x dx plus 2 to 3 f of x dx. Now, in the interval minus 2 to 2, f of x is nothing but e power cos x into sin x dx plus 2 to 3 f of x. Now, anything above 2 is 2 dx. So, Now this function is, let us say, f of x. If I substitute x as minus x, this will be an odd function. It will be minus of e power cos x into sin x. So odd function. If it is odd function, their integral will be 0 plus. Now integration of 2 is a constant, so it will be 2x, 2 to 3, which is nothing but 0 plus 6 minus 4, that is equals to 2. That is option C. Partial differential equation is, we have to find the partial differential equation of the function z is equals to f of x square minus y square. Now let us differentiate this z with respect to x partially. So it is dou z by dou x. Differentiation of f of x is f dash of x, and the differentiation of x square minus y square is 2x. Let it be some equation 1. Now we'll differentiate z with respect to y partially. So it is f dash of x square minus y square into differentiation is minus 2y, which is equation 2. Now we have 2x here and f dash of function. We have 2y here and f dash of function. If I multiply y to the first function and x to the second function and add, then the result will be 0. So it is y into dou z by dou x plus x into dou z by dou y will be equals to 0, which is nothing but option B.
Question is, the block diagram for a control system is shown below. For unit step change in the set point, the steady state of set in the output y of s is. We know that the steady state error equation, that is limit t tends to infinite ess, is nothing but s into r of s limit s tends to 0 1 plus g of s into h of s. Here h of s is 1, g of s is nothing but 2s, sorry, this is 4, numerator is 4, this is 2. So 4 by 2s plus 1, 3s plus 1 is the open loop transfer function. Here r of s is 1 by s. Hence steady state error ess equals to 1 by 1 plus limit s tends to 0 g of s, which is nothing but 1 by 1 plus 4, which is equals to 0.2. Hence option A is correct.
Of 300 kilowatt is driven by a prime mover of speed regulation 4%, and another alternator of 200 kilowatt is driven by a prime mover of speed regulation 3%. Okay, there is a shortcut for this type of questions. Okay, now what is the total load? P total is equal to, when you have these type of problems, take it as a shortcut. What is the lower kilowatt of an alternator here? Out of 300 and 200, only two alternators are connected in parallel. So it is 200 kilowatt plus 300 times of, okay, 3 by 4. This is the speed regulation of alternator 2 of 200 kilowatt by speed regulation of percentage alternator 1, that is of 4%. You will get around 425 kilowatt. Option B is correct answer.